Okay, guys. So yesterday we were doing about the transition elements, and in the transition elements, I have given you the complexes of the copper, and I asked you to make the complexes of the nickel and the cobalt by yourself, and write down the colors. Okay, the complexes they are exactly same, but the difference only lies in the colors. Colors भी लिखे किसी ने बेटा लिखने चाहिए आपको क्योंकि मैं जो क्वेश्चन करवाऊंगा वो कॉपर से रिलेटेड करवाऊंगा निकल एंड कोबाल्ट यू हैव टू डू इट बाय योरसेल्फ टुडे वी आर गोइंग टू स्टार्ट with a very important topic that is the ligand exchange. Okay, so that is transition element. भैया की स्टोरी शुरू हुई है. This is the longest topic. Ligand exchange. This is the name of the topic. Okay. Now to make you understand about this topic, I'm going to write down a question up here. Okay. So I would, you know, explain this whole question with respect to the copper complexes. And after that, I'm going to change the wording of the question. At the place of copper, I should write the nickel and the cobalt, and you do it by yourself at your home, so that it will, practice will make you perfect. If you don't find any nickel or cobalt from some book, you can consult the past paper. Past paper questions, they got the nickel and the cobalt complexes colors. Okay, you can find it from there, और Google करके वहां से चेक कर लें, कहीं से भी कोई सोर्स से चेक कर लें आप लोग, क्योंकि मुझे याद नहीं है, या मुझे याद होते मैं गलत भी लिख पाऊंगा यार, क्योंकि मैं ऐसे मिक्स करके ना, क्योंकि टीचर के हाथ से मिस्टेक हो जाए तो वो अच्छी चीज नहीं होती, क्योंकि इतने स्टूडेंट्स ने उसको फॉलो कर रहे हैं. तो मैं इसलिए एक्सक्यूज कर रहा हूँ, मुझे उनके कलर जो है ना मैं मिक्स कर जाता हूँ, मुझसे 2 बार पहले गलतियां हो चुकी हुई हैं, तो इसीलिए मैं उसको एक्सक्यूज कर रहा हूँ. दैट्स द रीजन. Okay, so I'm going to write down the question up here. The question is, when a few drops of aqueous ammonia are added in aqueous copper sulfate and then excess of aqueous ammonia is added in aqueous copper sulfate. Okay, so this is the question, my dear. I'm going to make you understand about it. This question actually, you people, if you have done the practicals, so you have done the same question in the practical, not the same question. I mean, the precipitate. Just imagine your A1 practicals or O level. You know that when you got the copper plus 2 ions, okay, so when you add the few drops of so when you add few drops of aqueous ammonia, okay, and when you add excess of aqueous ammonia. So what would happen if you got the copper plus 2 ions, my dear? If you add few drops of aqueous ammonia, the blue precipitate they are formed. And when you add excess of aqueous ammonia, the blue precipitate dissolves. Blue precipitate dissolves to form deep blue solution. Okay, so this was the thing you people have done it in your O levels. You have done in your practicals of the A1. If you got the copper plus 2 ion, when you add few drops of aqueous ammonia, it will form blue precipitate. When you add excess of aqueous ammonia, the blue precipitate they dissolves to form deep blue solution. Okay. Now we are going to discuss this one in respect of the complexes and the ligand exchange. Okay, the same question we are going to discuss, but with respect to ligand exchange and the complexes. Okay. Now, before starting this one, let me tell you a little bit about the aqueous copper sulfate. Copper sulfate, my dear students, if you dissolve it in water, this is just to make you understand about this question. This is not the answer of this question. This is just to make you understand about it. So when you add copper sulfate, it dissolves in water, and when it dissolves in water, it is going to form copper plus 2 ions, and you write aqueous for it, and SO4 minus 2 ion, you write aqueous for it as well. Okay, this is the ionic compound. The ionic compound is break down to form positive ion and negative ion. Okay, so copper plus 2 aqueous ion, what is this one actually? This copper plus 2 aqueous ion is actually copper that is surrounded by the water molecule, 6 ligands, and form the plus 2 charge, and you know that this one form the blue solution. Okay, so the blue color of the copper sulfate, that is actually when the copper plus 2 form a complex with the 6 water molecules, so that would form the blue solution. Copper sulfate, you know that if it is without water, it is anhydrous. In anhydrous form, it is white in color. It is not having any color. Okay, but when it dissolves in water, okay, so what would happen? The copper ions they form a complex with the water, and that is actually the blue color. Okay, so the blue solution is actually due to the formation of the complex of the copper ion with the water molecule. Did you get it? Muskan, Uzair, Yahya, beta, did you get it?
Yes, sir.
Okay. Now listen, now we are going to start with the question. The question, this is the basic thing. When you take the aqueous copper sulfate, in aqueous copper sulfate, these complexes are present, which are actually the blue solution. So now the first part of the question is, he is saying when a few drops of aqueous ammonia are added. So I'm just going to write when a few drops of aqueous ammonia are added in aqueous copper sulfate. Okay. So when a few drops of aqueous ammonia are added in aqueous copper sulfate, so what would happen? Uh, this is aqueous ammonia. So ammonia, my dear, it dissolves in water. Okay. So it is going to form, it's a weak alkali. So it is going to accept the H positive up here. So it would form NH4 positive and OH negative ions. So ammonia in the aqueous solution in the water, it's an alkali and it produces OH minus ions. So when you people add the aqueous ammonia in the copper sulfate, so what would happen? The concentration of OH minus ion that would increase. Okay, and keep remember when the amount of any particular ligand exchange, so what does that ligand do? It is going to displace the other ligand in the complex and would occupy its place. Okay, so now what would happen? Have a look up here. So you got this thing in the copper sulfate. So Cu H2O6 and having the positive 2 charge. So when the concentration of OH minus ion increases, so what would happen? The two OH minus, what they do, this is the reversible reaction. So the two OH minus, they would replace the two water molecules from here, two water molecules from here, And now what is the next thing formed? Copper, H2O4 and OH2, and this whole thing is having zero charge, and this one would form blue precipitate. So this is actually the blue solution. Okay. So because this is having the charge and this is zero. So this whole reaction, don't call it as a ligand exchange. It is the ligand exchange taking place, but precipitate is formed. So this whole reaction, that is called as the precipitation reaction. Don't call it as a ligand exchange. Why? Use the word ligand exchange when two people got the ion on one side and ion on the other side. If you got the solution on one side and you got the precipitate on the other side, so that reaction is precipitation reaction because precipitates, they are formed. Everyone got it, beta? Yes.
Yes, sir.
Okay, guys. So this is the precipitation reaction form. So basically, the blue precipitate which has been formed, that is due to the precipitation reaction. Okay, so you should write the wording up here. When when few drops of aqueous ammonia are added, the OH minus ions forms displace the two water ligands from CuH2O6 plus 2 charge to form blue precipitate CuH2O4 OH2 0 by precipitation reaction. Okay. So this is the first point, my dear, when you add few drops of aqueous ammonia. So few drops of aqueous ammonia mean that the concentration of ammonia is less, but the OH minus ion concentration that is greater. So what they do, they displace the two water molecules from the blue solution. Yeah.
सर अगर आप एडिड OH आयंस डिस्प्लेस सर इधर OH लिगेंड्स लिख सकते हो
हाँ OH ligands लिख दो ज्यादा बेहतर है बिल्कुल ठीक है OH minus ligands displace the two water ligands from this one to form blue precipitate by precipitation reaction. Yeah, that is more good. Okay, guys. Now the next thing, the same question. This is this is not you supposed to write. This is just for your information. Your answer is going to start from here. Okay, and normally they ask you this question about 4 marks. Okay, so 2 marks are for this one, and 2 marks I'm going to write the next one. Excess of aqueous ammonia added. So just have a look when excess of aqueous ammonia are added in aqueous copper sulfate. So when excess of aqueous ammonia are added in aqueous copper sulfate, then what would happen? Okay. Okay, guys, you know that ammonia that is actually a weak alkali. So when you take excess of aqueous ammonia, the concentration of ammonia that do increases, and ammonia is also a ligand. And ammonia is more powerful ligand than water and OH minus. It's a more powerful ligand. So what does it do, my dear? It is going to displace So have a look up here. Cu
फिर उधर भी एक ही नहीं लिखा
H2O4 and OH2. So this is the blue precipitate. Okay, blue precipitate. So when you add the excess of aqueous ammonia have got a more concentration of the ammonia. So now ammonia is the powerful ligand. So what does it do? It is going to displace the two water molecules from here. All the water molecules you can take. The four water molecules from here, the two OH minus from here, and you get Cu NH3 6 and positive 2 charge. So this thing that is having the deep blue solution. If you look the color of the complexes, I told you in the copper, सब कुछ same है, सारा कुछ same करना है, everything is same. Only the difference lies in the color. That's I'm saying. बाकी सब कुछ यही लिखना है, सिर्फ color का difference लिख दो बस. Okay? Okay, guys. So this is actually the ligand exchange reaction. This is the ligand exchange. This reaction is ligand exchange. It's not the precipitation because if you look up here, this zero has changed into the +2 ion. So precipitate would change into ion. So that is the ligand exchange. But if the ion change into precipitate, that would be more suitable to call it as a precipitation reaction instead of ligand exchange. Okay, so you should write up here when we add excess of aqueous ammonia, the concentration of ammonia ligand increases, which displace the water, the H2O and OH minus ligand from a blue precipitate Cu H2O4 OH2 and 0 to form a new complex of deep blue solution and that is copper with ammonia and having the +2 charge. Okay. So this is the answer, my dear, you should write. Okay. When they are going to ask you, and what they can do, they can at the place of this copper sulfate, everybody just look at the place of this copper sulfate, they can write nickel sulfate or they can write cobalt sulfate. Okay, up here the same thing, nickel sulfate or cobalt sulfate, like that. The colors are different only, but the reactions they would remain same. At the place of copper, you should write nickel or cobalt. The colors are different. Answer का तरीका का यही है, same. You only have to write down, the color difference. Uzair, Muskan, and Yanya beta, did you get the concept? What you are supposed to write?
Yes.
जी सर.
Yes, sir.
Okay, guys. The next question normally they ask, when concentrated hydrochloric acid or concentrated sodium chloride solution, this is also called as the brine, is added in aqueous copper sulfate. Okay. Okay, guys. So aqueous copper sulfate means you only need the copper with 6 water molecules present. So this is meant by that. Okay. So you got copper with 6 water ligand and having the +2 charge. So this is actually the aqueous copper sulfate. This is actually the blue solution. Okay. So when you add the concentrated hydrochloric acid or the brine solution inside it, so what would happen? Both of these things, they produces the chloride ions. Chloride ions, they are also act as a ligand when the concentration of the chloride ion increases, because these are the concentrated things. In the concentrated solutions, the concentration of the chloride ion that is greater. So what would happen, guys? These chloride ions, what they do, they are going to replace the 6 water molecules from here, and you will get a new complex CuCl4 negative 2. If you look at the color of the complexes, color of the copper complexes, so CuCl4 negative 2, that is actually formed the yellow solution. Did you get it? Okay. So when concentrated hydrochloric acid is added in aqueous copper sulfate, the color of solution changes from blue to yellow due to ligand exchange, as Cl minus ligand displays the water ligand H2O ligand from Cu H2O6 plus 2 to form CuCl4 negative 2, yellow solution. Okay. Okay, guys, this is when you add concentrated hydrochloric acid. And the next thing, when dilute HCl is added in aqueous copper sulfate. So everybody just look. If you look, CuH2O6 plus 2 charge plus 4 chloride ions. So 6 water molecules and CuCl4 negative 2. Okay, so this one form the blue solution and this one form the yellow solution. Now, when you take the dilute HCl, guys, just listen. When you take the dilute HCl, in the dilute HCl, the chloride ion concentration is that is not too much. So some of the complexes would form this yellow complex, and some would remain in the blue complex. So blue and yellow both are present in the dilute HCl. So blue and yellow, they both mix each other to form the green color. So green solution. Okay. So in the dilute HCl, some of these complexes, blue complexes, they would change into yellow complexes, and some would remain in the blue complexes. So blue and yellow, that would mix with each other to form the green solution. Up here, have a look up here. If you got the concentrated solution, so the concentration of chloride ion is greater, so equilibrium shift to that side. But in the yellow solution, if you add water is added from outside. So concentration of water increases, so this one would shift on that side as well. So some would remain blue and some would remain yellow. So the color would become orange as well. Did you get it? तो यहाँ पे भी उल्टा काम हो सकता है. So keep this thing in your mind. Okay. So in the dilute HCl, sorry, when we add dilute HCl in aqueous copper sulfate, both complexes blue CuH2O6 plus 2 charge and yellow CuCl4 negative 2 would remain in the solution and color of solution would be green. Okay.